In today's video, I'm gonna tell you how to configure linear external axis for ABB robot. As you can see, what typically track linear additional axis is commonly used in our project. As a linear axis, it's a seventh external axis in robot. So today's topic is how to configure this linear track additional axis for ABB robot, particularly with RRC5. Okay, this is the topic. So before we go to the topic, you have to make sure you already installed the options for additional axis, which is ADU 790A in position X3. Typically, we can install three external axes for ABB robot X, Y, Z. Right now, in this topic, we only need one, so we must confirm this option already installed. Still, if you don't buy this option from ABB robot, go back to the previous video to check what are we going to do to achieve this option without buying. Introduced in previous. So after you confirmed the system you already installed this option, then the next you need to configure the files, CFG files, MOC files, where you can find it, because this CFG file is for additional axis configuration. So you have to check add in and find the correct robotware version which is correspondent with your project. For example, your robotware is this one. You click on it and you find positioner. You open the package folder and you open the robot package. You open the track motion, robotware, utility, additional axis, track, because our application is track. Okay, you get it. Our application is track, so we choose track. Typically, we choose DM1. We copy. This is the CFG file, MOC file. As you can see, the property. I'm gonna open it. This is the robot configuration file. Typically, you use this file to configure the track linear, the linear additional file. This is the module, this is the standard file, but you have to modify it. So you copy this file, copy it, and you open it in notepad. Remember? You open it in notepad. As you can see, MOC CFG file. This file, a lot of people would tell you just import it into the Robot Studio or Teach Pendant to modify it. My solution is suggest you open it in notepad to change it. So let's begin the topic. First, mechanical unit. The name of this axis, you can change you can change this the axis name in this file, and we enable two functions under this option mechanical unit. Activate the additional axis at startup. Deactivation forbidden also enable these two functions for this option. Okay, and this keep default. Single type still name, you can change it. Single type because the mechanical is track, it's linear axis. Okay, so we define it's a linear, so we define it track. And you also can define free rotary table or silver gun or external position. These variables you can type it. Okay, but this case is track, linear axis for the single type. For the joint just keep it logic axis 7, and measurement channel keep it. Arm, okay, arm is very important, still name you can change it. And for the upper joint bound or lower joint bound, this is for the limitation for up or lower position, depends on the situation. The unit is meter, remember the unit is meter. So let's open this picture, which means you have to set the limitation left or right, the track, upper or lower limitation, linear, you get it, based on the situation. You type the number, okay, you type the number. And in the linear addition, in the linear axis, you also have the original position. So original position, upper position, and the lower position, 3 position, original position, lower position, and upper position. This is 3 parameters you have to pay attention. For the original position, I'm going to introduce in the later. So this is the lower limit, upper limit, you get it, you have the concept. Okay, you type the specific value according to your situation. And arm type, you just type the name. This is the Excel data, which means this is for the acceleration, deceleration time setting. You get it? You can type the second time. Transmission, this is for the transmission gear ratio setting. Transmission gear ratio setting. And this number you have to commission based on the real situation. So what does that mean? For example, if on the teach pendant you jog, for example, if on the teach pendant you jog the linear, the external axis 10 millimeters or 10 meters, let's assume you just move, and this number will change. For example, let's move 10 meters or 10 millimeters, centimeters, and you will check whether the linear, the robot exactly move 10 meters or not. If the number is not equal with this position shows on teach pendant, you have to adjust this transmission gear ratio, because sometimes it's not the theory number, you have to commission. So you get it, you compare the position number on teach pendant and check the real distance the robot already moved. If equal, then type the right number. If not, just change it. Okay? Transmission. Typically, the transmission suppliers will provide it to you, but depends on the commissioning side. Brake. This is keep it default. Also supervision type, keep it. And motor is important. The name you can change it. Motor type, you can type serial number. Basically, the motor should be ABB MU motor. Remember, MU motor. Okay. MU motor. Type the serial number. Motor type is the motor parameters such as power pairs, torque, here, current, motor current, and phase resistance. You can type the number. Phase inductance. Okay. These motor parameters you can check on the label of the motor. Remember, basically we use ABB official MU motor for linear axis. Get it? And stress duty cycle. Stress duty cycle is their name, and speed absolute maximum. Typically we have to type the current. This is the max current. Okay? You have to change it. You have to adjust it. And the last option is this one, LCMO. What does that mean? It means lag control master. And we have 3 parameters. These 3 parameters needs to be adjusted by ABB Tune Master software. KP, KV, TI, these values you need to get it. You need to adjust it by ABB Tune Master software. And this software, you can open it. You can open the software. First, still, you connect your laptop to X2 port, Ethernet port. And open the software. Choose additional axis. And this is the X2 port IP. And once robot online, you choose additional axis. Okay, choose additional axis. As you can see, Tune KV, Tune TI, Tune KP. For the position, you type the robot position you want robot to retain. You just type the current position or whatever you want the robot to remain. And the move means you want the track, you want a linear axis to move the distance. Type here. First, you have to adjust the Tune KV. Then you type it. You want to adjust. And also for TI, also for KP. And once you set it for the position and move, you get started. And this software will calculate the exact value for you. Okay? And a lot of people would worry, what does this three parameters mean, I'm gonna explain it. I'm gonna elaborate on it. KP, this file, typically this key V, let's begin with the key V. Key V, these parameters, the range typically is 0.5 to 2. The bigger number is the load for this linear axis heavier. And once key V is fixed, the KP parameters, the bigger this parameter is, the positioning response is more quicker. For TI, these parameters typically is 0.1. The smaller this parameter, the quicker response is. Okay, you have to just adjust it one more time. Additional axis, connect to X2 port and choose axis 7, and you can choose the robot position set and the linear additional, the track move position, tap here, and first begin with the key V, type the value you want to adjust, and to TI KP same, and get started. Then the value you will get it. Once it's better, then you can change it into the robot, into this file. Okay, this is the entire parameters you need to modify on the CFG file for the track axis. And also there is another parameters you need to change, which is here, is configuration, motion and robot. You can base frame moved by, you have to choose it. Right now we don't access request. We have to get restarted, I think. So I'm gonna get it restarted. Wait a second. Restarted. Okay. Wait a second. Okay. We restarted. Granted. Okay. Still, base frame moved by, you choose the linear axis. Okay, you get it. Okay, and revoke jog. As you can see, typically when and once you already successfully adjust the CFG file, you have to import it. You have to load this file into the robot. Where you can load it, you can buy the Robot Studio, or you can do here, configuration, motion. So you can load parameters. Okay, you can operate on teach pendant, or you can just operate it here. Install it. You can request request, or you can just put the CFG file into your laptop. You can load it in by the Robot Studio load parameters, choose that file, you get it. I think it's more convenient by Robot Studio. You choose that file, load it, and the file will load it, then you just write to the robot system. Once you successfully load it into the robot system, I mean, you can either operate it by Teach Pendant or the Robot Studio. You just write it and download it into it. Okay? Because on the Teach Pendant you load and replace, and you can choose. Okay, you can choose the USB. You get it? Typically you can put that CFG file in the USB. Then you can load it. Okay? Then once you finish this loading, you can see the axis. Here we are here. You can choose, you can change to the basic axis to the additional axis. Okay? And the next step, you have to calibrate the 0 position, home position. You choose the calibrate. You choose the external position. You choose the calibrate parameters. Fine calibration. Okay. Then you move the robot. You move the robot to the original home position you define. Then finish this definition for home position. Okay. This is the operation. And a lot of people also can edit or modify this CFG file in Robot Studio, but depends on the real situation. I prefer open it or edit in notepad. Depends on the situation. Okay, so this is today's video. Still, if you are master of ABB robot, ignore this video. If you are beginners, hopefully it's useful for you. See you next video.